This exercise, which has several parts, is concerned with applications of determinants to analytical geometry. There are two concerned with computing areas, one concerned with a volume, and one with the equation of a plane, and so on. It turns out that many of these kinds of problems are easily solvable with determinants. Let's just take them one at a time. In part A, well, there's actually subdivided into two parts. We have to compute the area of parallelograms given their vertices. I'll give you the formula in a moment. I just want to, you might be wondering, why did I write these in gray, this fourth point? Turns out that for a parallelogram, you really only need 3 points. I mean, if you think about it, if I'm given this point and this point and this point, that completely determines the parallelogram, because the fourth point has to go in such a way that it's this line's parallel to this and this is parallel to this. So we don't really need the fourth point, but it was given, so I just made it in a different shade. Okay, now the formula, given 3 points, here it is. The first column are the x-coordinates of the 3 points, A, B, and C. Well, I haven't labeled them. In a moment. And then the second column of the y-coordinates of A, B, and C in such a way that they're in order. I mean, A here, B here, C here, as long as we're consistent. I will mention something small and technical, and you can ignore this if it's confusing. But just to be precise, you might say, I don't know which is A, which is B, and which is C. And in a way, we don't. And actually, if we have ABC, it really forms a triangle. There's really two places we could put D. D could be here, but it could also be, if we make this parallel and this parallel, D could also be here. So we might be getting this parallelogram, but they both have the same area because they're both twice the triangle. So it doesn't really matter. I just mentioned this to be technically correct, watertight. But don't worry about it. You just put the 3 points that you know, and that's the formula. Okay. Now in our case, I'm first going to substitute 005265, and then these three. They're going to disappear off screen, so should have noted them anyway. Here are the 3 points, 005265, and here are all ones. Oh, and I forgot to mention about the plus minus. S is the area, of course. The plus minus is just in case this comes out to be negative, then we take a minus here to make it come out positive, because we want the areas all to come out positive. I could have said absolute value, but it's just hard to write absolute value around a determinant. It's also 2 vertical bars, so put plus or minus means take the plus of this answer. Okay, so here we're going to expand by the top row, obviously, and then we only have the single non-zero entry, and this is a plus minus plus, so it's just the determinant 5 times 5 minus 6 times 2, which is 25, minus 12 is 13. The plus or minus, we took the plus. It's 13, and that's the answer to the first part. And the same formula with the other set of points. This time I'll expand along the first column. So I have 2 non-zero entries. I have this and I have this. For the minus 1, the determinant is 5 times 1 minus 4 times 1. It's 5 plus 4 times the minus 1. And for the 1, this is multiplied by the minor, which is 0 minus 5. So what we get here, this time it's going to be negative. We have minus 9 minus 5, which is minus 14. So this time we pick the minus and we make it plus 14. Okay, that's part A. Now on to part B. Now in part B I'm going to give you a formula for the volume of the tetrahedron, but I just thought maybe you don't know what a tetrahedron is, or you've forgotten. It doesn't really matter because we could just use the formula, but a tetrahedron is also called a triangular pyramid. The tetra comes from 4 and the hedron is from faces. It has 4 faces. If we take points A, B, C and D, then it might look like this, and the hidden edge here, and there's an edge here. It's a triangular pyramid, and the A, B, C, D are the, doesn't matter in what order, the 4 vertices of this thing. Okay, so the general formula for the volume, V is volume, is, as in the previous exercise, we have a plus or minus, which just means that we want the answer to be positive, and if this determinant comes out negative, then we apply the minus part to make it positive. The points, and there's 4 of them, these are the coordinates, the XYZ of A, the XYZ of B, the XYZ of C, the XYZ of D, and the 4th column is always just ones. So if you go back and look at the numbers that we had in our case, they were given as 0, 0, 0. This was the 2nd point, this was the 3rd point, and this was the 4th point. Now we just have to compute a 4 by 4 determinant. So let's see what will be good. I think expansion along the first row.